Hello, welcome back. Yeah, again, good job for getting this far into the course. Many would have decided to turn away, but you chose to put up with my antics a little bit and delve deeper into this pretty interesting language. And give yourself a pat on the back. You made it this far. On today's menu, we're gonna take a look at how we can organize larger code bases and the difference between crates, packages, and more specifically, what a library crate is and a binary crate is. Let's actually start with that first. So far, we've been dealing with binary crates. If we want to be precise, a crate is a single glob of code that can be compiled at a time. This could even be considered a single file, like a main.rs that we've been dealing with pretty much every time we have coded something. When we say a crate is a binary crate, we're saying that the code we're writing is meant to be run as an executable. And I know I'm not doing anything on the screen at the moment. I think it's best to describe it first and then delve into some examples. Yeah, Arnold thinks the same. The other type of crate out there is called a library crate, and that is typically what people refer to when they just say a crate. It is a library crate. Instead of running as a program, library crates are meant to be imported into other projects or be used in binary crates. And a package is a collection of crates and is at most one library crate and zero or more binary crates. For example, we could have a package that just has a library crate and is meant to be used by other crates. Or we could have a library crate in our package that specifies the shared logic or types between a client and a server binary. And I actually have a very fancy sketch of how this might look like in a package. And a package is what we've been creating with Cargo New. So, here's super fancy, right? So we create this package with Cargo New, and our main.rs is a binary crate, but in the demo I'm going to be making, we're going to have two binary crates, a client.rs and a server.rs. And if you've been following along with these examples or these exercises that I've been making for the video, as you can see, we're using a library crate. And we're exposing modules for each video. And we're basically making these modules accessible by the library crate over here, which acts as our crate root. So I'll go back to my fancy example. And again, what I just showed would only be a library crate. And these other files, video 2, video 3, video 6, are modules that expose their functionality to the library crate, which in turn exposes it outside of the package. Well, not outside of the package in this case with the exercises, but if I wanted to use the functionality that I provided, let's say in video 2, I would go ahead and make that public, and I could make a function here, this like add 5, and here's the solutions in case you haven't done it yet. I could do like public function add 5, and now I'd be able to use that add 5 function outside of the package, which is what we created with Cargo New. And as you can see, our Cargo 2ML lives inside the package. Makes sense, right? And with our demo, we're going to be, again, making a network module that lives in network.rs. And we're also going to make a struct that is shared between the client and the server binary crates. So I'll get started with that actually. To start, let's focus on, well, we got to make a package first, and then let's define our library. So first of all, I'll create a new project with Cargo New, and this is a package. When we make anything with Cargo New, we're making a new package. Cargo New, and I can use this --lib flag that gives us a library crate outside of the box with some boilerplate code. So Cargo New --lib, and I'll say network demo. And I'll go ahead and cd into our network demo now. And as you can see in our source folder, we now have a lib.rs with some boilerplate code. We're going to delete this, but it's good to take a look at this and see if you can understand what's going on. So we're exposing add. Anytime that we add a pub keyword to the root of a crate, especially, or the root of a library crate, we're exposing that so it can be used in other crates. So we're actually going to go ahead and do that and import a couple of, or should I say include a couple of external crates in our project. We've done this with random before, but I'm going to do it with a couple of new dependencies, Serde and BinCode. I'm just going to go ahead and yoink a dependency section into here. So this features key allows us to specify which parts of the package we actually want to include. What we're using from Serde and BinCode are exposed from their library by them having a public keyword in front of different modules, functions, types, etc., etc., etc. Or we're just importing the derive feature, and we'll be going over this in more detail later, but in this case we want to apply the serialize and deserialize traits from Serde into our message structure. Our message structure, which is going to be this guy down here. We're then going to be using BinCode to call those derived those derived traits into actually create our buffers and to deconstruct our buffers into message structs. Don't worry if this is a bit confusing right now. We're basically just using these dependencies to serialize and deserialize our message struct, so that we can send it over the network. And feel free to poke around with these crates on your own time and really understand what's going on under the hood after the video. It's okay. Again, we haven't covered some of the things I just discussed, like traits or what's going on with derive. So I'll go to our library crate root, and I'm going ahead and just delete all this. And we need the serialize and deserialize features from Serde, so go ahead and use Serde. And again, these are exposed with the public keyword. So, and same with anything else that we've been importing with use outside of our crate root. So we need a deserialize and a serialize. And again, don't freak out if you don't understand what's going on here. We're basically just, this is going to basically make a couple of macros for us that specify how serialize and deserialize are implemented. Deserialize, and we're also going to use the debug trait of our public structure message. And we're going to have, again, we got to specify public everywhere that we want things to be exposed. We want a nonce, and we're just going to, all this is going to be is just a number we increment by 1 from the server. It's going to be unsigned 32-bit, and contents of type string. Now, if we went ahead and tried importing this into another crate, we would get the message struct, but we wouldn't get access to any of these fields. These would be considered private right now. So I want these to be editable. So I'll do pub nonce pub contents. And again, this message will be sent and received by both our client and server. So that's why it's public. Let's create some boilerplate code for our client and our server at this point. I'll create a bin folder, which will contain the entry points client and server.rs. These function just like our main.rs, except if we want multiple binaries, instead of having a main.rs, we're going to have a bin with our binary crates in them. So I'll create a server.rs and a client.rs. I'll actually start with our client first, so our entry point main, which the compiler is going to find this and say, oh, this is where execution should start in our binary crate. So we want to craft a message to send to the server, right? And let's import our message from the library crate root. And in order to access our library crate root, we're going to use the package name. So use in our package name in this case, as we can see from cargo.toml, it's network demo. So use network demo : to drill down, and we're going to be using our message struct. We're also going to need to be working with TCP streams. And again, feel free to look into the documentation of these extra types that we're importing in your own time, but I'm just going to be glossing over them for the sake of the length of this video. But we're going to be using a TCP stream. And let's craft our message. It'll be the server's job to add one to our nonce. So let message equal message. And we're going to just start with 0. And then the contents of our message are going to be ping. And of course, this is a string slice. It needs to be a string instance. So toString. Great. We will then need to connect to our server. And to do so, we're gonna, and again, feel free to look this up on your own time, but let mute stream, our TCP string, equal a TCP string, and we're connecting to localhost, if I can type, and we're gonna be using port 7878. And this is gonna be a result type, so we can unwrap the value of the result if it's okay using expect. And if we get an error instead of okay, we're going to panic with this message: could not connect to the server. And again, this is using the result type, which we should be a little bit familiar with at this point. And then we could debug connected to server. We then need a way to send our data to the server and then receive a response and print the response, and that'll be the contents of our client. That's all it's going to do. Now, moving on to the server binary crate, we do have a main function, and I just went ahead and imported these types that we're going to be using, or these modules, or in this case a struct. So first of all, we are going to be binding a socket to port 7878, and we're going to do so by doing TCP listener bind localhost 7878. And again, this is a result type, so we're going to expect that this works. Otherwise, we're going to say failed to bind to 7878. Sad. We can then do a little bit of a debug here. We'll debug. Or you know what? It makes more sense to print ln here because otherwise we're just going to get, the value. It's a little bit cleaner if we do a print line. And I'll do that in our client as well. So we're listening on 7878. And again, feel free to look at the documentation, but for each TCP stream that we get in our socket, this is just going to iterate. It's never going to exit this loop. It's basically while true, get a new stream or wait for a new connection. And again, this is a result type. So what we're going to do here is shadow stream. Stream is going to be a stream. We expect it to be okay. Otherwise, failed to handshake with client. And then we're going to want to handle connecting to our client. And we'll make a function down here. And this is going to take in and consume a mutable stream. And we're going to call it here. And we need to receive our message from the stream, create a message to send back, and send our response to the client. So we need a send data and a receive data function, which are going to live within our network.rs module. So starting with send data, let me make a new module, network.rs, and I'll create a pub function send data. And this is the same as saying mod network function send data. We could very well write all of our function send data and receive data stuff within our, not in server, in library. We could write all of our functionality here, but we're trying to organize our repository, our package a little bit better. So it's the exact same thing if we specify files within our source directory. So to get access to this module that we just wrote in network, we write mod network. This is kind of like redeclaring it a little bit, but without writing function send data blah blah blah. By writing just mod network, we're basically saying, okay, include network in this file, because network is a child of lib.rs in this case. We could even go a step further, and if we wanted to make a child of network.rs, we would create a folder called network, and I could have something like foo.rs in here, and I could have a public function foo, which doesn't do anything, and then I could go back to my network.rs and say mod foo, and now we would have access to our foo function. Although we're not going to do that in this case. We're just dealing with a single module network. But again, that's the exact same thing as writing something like mod foo, function foo. It's the exact same thing writing this if we created a folder called network that has a foo module in it. So I'll go ahead and delete that real quick. So to access the parent of the network module, which in this case would be the library create root, the parent, and same idea. If we had that foo example, if we wanted to access the network module, we would use super, and that's just going up to the parent, super, and we want message, pub struct message, and I gotta actually use it. We're also gonna be using the TCP string type again, and we're also gonna be using the traits read and write so that we can, and again, we'll go over traits later. But now we'll use a stream, which is a pointer to a TCP stream, and then we want to actually consume our message. So we'll pass ownership of message, and we'll let our byte array, our buffer to send, be, and we're going to use the bin code, crate, serialize, message, pointer to message, and if it, again, it's going to be a result if we aren't able to serialize it, we'll just crash the program with failed to serialize. And we're going to first send the number of bytes that our message struct is to the network so that we know how many bytes to read from the network. So we're going to let length equal to bytes.length, and bytes is just a vector type as an unsigned 32-bit. And then we want to write to our TCP stream the length to big endian bytes, failed to send. So now at this point we've just sent the length of our byte array over the network. Now we want to actually send everything. And we're going to send a reference, or give write all a reference to our byte array. Expect failed to send message. And I'll say failed to send length. Great, now we have our send data. Let's go ahead and continue. Pub function receive data. It's going to take in a stream, mutable reference to a TCP stream. And in this case, it's going to return a message. So I'll first get the length of our message, and this is going to be a byte array. And we also have this shorthand way of, instead of annotating like U8, we can instead infer we want this to be all zeros of type U8, and we want 4 of them, 4 bytes, because that makes up our U32. And then we're going to read exactly 4 bytes into our length bytes array. Expect failed to get message length. If I can type. And then we can let our length equal from big endian length bytes. And again, this is just a function on the U32 type. And yeah, we'll cast it to usize. And the reason we're casting it as usize is because that's what we need in order to make a vector of a certain length. So I'll do let mute buffer equals a new vector of a bunch of 0 unsigned 8-bit integers of length lang. And again, the compiler will be friendly about you if you didn't cast it as usize. See, mismatched types. We're going to then read into our buffer from the TCP stream. And then finally, we're going to call our bin code deserialize buffer. And then failed to deserialize message. And we need to pass in the generic message. We do so like this, and again, we're going to go over generics later. Just know that we're basically saying we want to deserialize it to a type of message. Oops, there we go. And we'll go ahead and fix that up here. Great, so now we have the core functionality of our networking program. And they are exposed to our library through the public keyword. Now at this point, they're not visible to client and server yet. We have basically said, okay, let's include the network file with mod network, but now we want network to be accessible outside of the library crate, and we do so with the pub mod network statement right here. Okay, home stretch in this video. I know this is a long one. Go ahead and use network demo, network module, and we're gonna import multiple things at the same time with curly brackets, as we did with down here, TCP listener and TCP string. We can do receive data, send data. We could also do wildcard, and that imports everything, but that's typically bad practice, as you know, we might be adding things to the network module that we don't want to include later. So we're gonna do receive data, send data. Great. Now we're gonna use that receive data function. And let's print it out. And let's increment the nonce by 1. Then let's create our message. And we're going to say pong back to the client. And we're going to actually send it. And that's it for our server. And what did I do here? Oh, whoops. So for our client, we're just going to fill this part in. Pretty easy. We're going to take in the network module again in the send and receive data functions. Then we're going to send our data to the server. And we're going to send a mutable reference to the stream. We're going to send our message with all the logic we wrote. And let's receive a response. And let's print out our received message. That should be it. Okay, so now that we're done, we can boot up our server with cargo run bin server. And I'll open a new terminal window here. Then cargo run bin client. And we got Pong back from the server with a nonce of 1. As you can see, the server received a ping message from our client, and it's using this shared message type that we constructed in our library crate. Hopefully this helps out in terms of understanding how cargo packages are constructed and the difference between a library crate and binary crates, and how to expose different code modules to different parts of your project.